So 50% of your assessment will be from coursework pieces. You will have a final project. You'll have a mid-module test that will be graded, and you'll have individual coursework pieces that will form part of the 50%. And of course, at the end of it all, you'll have a final assessment. All right, so that is how we will be assessing this course. So as I said earlier, Unit 1 looks at data management principles. So we look at basic concepts as it relates to data structure. Look at some of the primitive data types that you will have studied in your programming course. We look at information and the importance of it in decision making. In Unit 2, we're going to be looking at graph theory. All right, so we look at how to implement graphs and how the graph theory informs data representation on the computer. You'll also spend some time in Unit 3 looking at how we implement different data structures using the C++ language. All right, so most of you have studied C++, as I said earlier, so we will be using C++ to implement different data structures. And finally, in Unit 5, we will be looking at file processing. All right, so this class will take different shapes, different forms. So we'll have engaging activities online. We will have our synchronous session. And of course, you will be provided with enough time to practice, to develop your skills in order to master the implementation of the different data structures. All right, so once you apply yourself, you have to practice just like any other course in computer science. You have to practice, put whatever you learn into practice, and of course, you will get through this course successfully. All right, is there any queries, any question at this time? And I should also say that on the eCampus, you can find the course outline, and that is where you'll find the weekly schedule or the lecture for each week and other course-related materials. You'll also find your assessment pieces there as well. All right. Any question? If there's any question, I'll take them now.
Sir, I just have one question, sir. Are you sure when the course itself would be on the Aaron system, so persons can go ahead and choose it?
Or the HOD is working on it. I understand that it would. Well, I was told, based on what I was told, the HOD is working on it. So by tomorrow, hopefully, let's see.
All right then, sir. I appreciate it. I understand.
Okay. All right. If there is no further questions, I'm gonna start by sharing a video with you. So we're gonna watch this video for about 5 minutes. Then we will go into what is planned for today.
And in this presentation, I will introduce what data structure is and some real-life examples of data structures. So let's get started. Before understanding what data structure is, let's first try to understand what is data. This is a prerequisite, okay? The better definition could be a dictionary definition. So let's see what is the dictionary definition of data. The quantities, characters, or symbols on which operations are performed by a computer, which may be stored and transmitted in the form of electrical signals and recorded on magnetic, optical, or mechanical recording media. This is what data is. You can think of a data as quantities, characters, or symbols on which we can perform operations, we can store them, we can transmit them, obviously in the form of electrical signals in our computer, right? So this is what a data is. Now let's see one example here. Here in this case, I'm performing this operation on these two data, right? We can think of these two as data because we are performing operations on them. These are just quantities, right? We can store them, transmit them. So they are satisfying the properties of data. So I can say that these are my data. Now, let's try to understand when data becomes information. There is a distinction between data and an information, and it is one such topic which is very confusing. We often interchange these two terms, right? But there is a distinction between data and information. Let's try to understand what is that. When I say just collection of characters like this or collection of symbols like this, then this is just a data. Because it is just a collection of characters, I won't be able to understand it properly, right? Could you be able to tell me what exactly I've written over here? No, right? But when I process this data and let's say I reverse this whole string, means the last character becomes the first character, second last character becomes the second character, and so on, then it becomes an information. Because now I can read this and I can understand what is written. Here I have written my name is Jaspreet. So it is quite understandable. So I can say that now here data becomes information because I can extract some meaning from it. So if data is arranged in a systematic way, then it gets a structure and become meaningful. Here I have arranged the data in such a way that it becomes meaningful for me. Therefore, I can say that this meaningful or processed data is called information. Now, it is not difficult for us to understand that the data needs to be managed in such a way so that it can produce some meaningful information. We need to arrange our data, we need to manage our data in such a way so that we can produce some meaningful information. To provide an appropriate way to structure the data, we need to know about data structures. That is why it is so useful to understand data structures. Data structure gives us the way to structure the data, to appropriately manage the data so that we can get some meaningful information from it. And not only that, we can use it whenever required in an efficient way. This is the reason why companies are preferring this subject over other subjects, because this is very important subject, right?
2020 high school graduates across Jamaica, be a part of the Ministry of
Structure. A data structure is the systematic way to organize data so that it can be used efficiently. So organizing the data in such a way so that we can use it efficiently is what data structure is all about. We are arranging the data, we are organizing the data, we are managing the data in such a way so that we can use it efficiently. When I say efficiency, I mean in terms of time as well as space. Let's see one example of a classical data structure, arrays. We have used it many number of times. We can think of it as a sequence or collection of some symbols, characters, integers, floats, or something like that, right? You can think of array as a data structure because it is helping us in managing the data in an appropriate way, actually in a sequential manner. Now here is an example why this data structure is so useful. Instead of creating multiple variables of same type, why not create an array to store all the values? Let's say I need 100 integers. Why do I require to create 100 variables for 100 integers when I can create a single array and store all the integers in them? Isn't that so? That is why arrays are so useful. Or you can think of one example like storing strings. You know that strings are nothing but sequence of characters, right? Let's say a string consists of 100 such characters. Now, are you going to create 100 variables for that? No, you can create one array which can store that whole string and we would be able to access it very easily. Isn't that so? So this requires array, and that is why we need arrays, because it helps us in managing our data in an appropriate way. That is why it is a very useful data structure for us. Now, let's discuss some real-life examples of data structures to help understand why do we need data structures. Here is an example. Did you know that stack data structure is used in implementing redo and undo feature? You know, this is the famous feature which we are using many number of times in our applications, right? One such application is Google Docs or PowerPoint or Microsoft Word. Redo and undo feature is very famous. But did you know that stack data structure is used in implementing this feature? Let's see how. Here I have taken an interface of Google Docs. Here I'm going to write something. Let's say I have written the primary goal of Nesser Academy is to give quality education. I want to write education here, but I forgot to mention here you. So instead I have written education, something like that. Let me tell you that here a stack is maintained where each and every information that I have entered gets stored. Like in this case, quality is stored, ed is stored separately, cation is stored separately. So this is our undo stack. Okay, we know that in stack the data is placed from top, and whenever we want to get the data, we can get it from the top. Only the top element we can access, right? Now, when I press Ctrl Z, then I know it means undo, right? So what it does is it selects the top element and it pops that element out of the stack and placed it in the redo stack. That is why we can see here that cation get removed when I press Ctrl Z. Ctrl Z means undo the operation which I have performed. Here in this case I have entered cation. I just can remove that out of the stack, and then after that, that particular element will get placed within this redo stack. Why it is placed in this another stack? Because when I press Ctrl Y, that is redo, then we can get that again. That is this cation, I would be able to get that again over here. Maybe I want to redo my operation. That is why redo stack is also required. Now I can continue writing. I have written the primary goal of Nesser Academy is to give quality education to, actually I want to write everyone, but accidentally I have written every instead of every. I press Ctrl Z, this element gets selected, and it will get popped out of the stack and it will get placed within this redo stack. And you can see here the operation is undone, right? Now let's say I want to redo the operation. When I click on Ctrl Y, then this particular element gets selected and it will get popped out of the stack and will get pushed within this undo stack once again. So here the operation is redone. This is how undo redo feature works. And this is one such application of data structure. And you can see here stack is our data structure. Now let's see another example.
In today's shifting world, it's time to pivot, or you could be left behind. How would you like to be taught how to pivot from Tony Robbins, Jenna Kutcher?
Which data structure is used to store an image as a bitmap? Do you know which data structure is used to store an image as a bitmap? There are two types of images, bitmap images and vector images. Now, when I talk about a bitmap image, do you know which data structure is used to store that image? Guess what? It is an array. Array is so useful that it is used in storing an image as well. Let's see how. Bitmap images are stored as a series of tiny dots called pixels, right? So here you can see in this image that these tiny dots or squares are called pixels. Here each pixel is actually a small square that is assigned a color and then arranged in a pattern to form an image like the following. So you can think of a two-dimensional array like this. Here in this example, it is 37 cross 40. Now within that two-dimensional array, you're storing pixel information. That is each pixel color you're storing. And then after that, you're arranging it in a systematic way. And finally, we get this as a result. That is an image of a Pikachu, right? So a two-dimensional array of size 37 cross 40 is enough to store this images. And that's so.
Let me see if we were actually watching the video. Can someone identify three of the data structures that were mentioned in the video and give me an example how at least one of them is used?
There's stock data structure.
Yes, the stock data structure. Shadow?
Bitmap.
Map or graph?
Yeah.
Yeah. Which other one do we have?
For Gabriel, talk. Go ahead.
Sorry, we have the start data structure, the bitmap, and the graph.
Future.
Okay.
You want example?
Yes, give me an example of how each is used.
All right, sir, I can give you an example for the data, the stock data. The stock data is used in the popular undo and redo feature that we use every day.
Right.
Yeah.
Okay.
Somebody else time now.
Somebody else can share. One more.
So the bitmap uses array in order to actually uses array to put like the different pixels in order to get pixels in order to present a picture.
Structure. All right. Good. All right. So we have the array, the stock. Good. So there's, and of course, you would have noticed that we use also the graph, like Facebook use graph and so forth. All right. So there are many data structures, and through the course, you will be exposed to them, and you'll get a chance to implement them to actually see how they actually work. In terms of reference, here's a text that you can use, data structure and algorithm analysis in C++. If you do a good Google search, you may be able to find a PDF copy online. As it relates to today's session, here is our outline. We will be exploring what a data structure is, and we'll also be looking at some other basic concepts, some of which were mentioned in the video. All right, so based on the video presentation, we would have gathered that data structure is basically a method or a way of organizing our data in the computer for efficiency. All right, so we can look at it as the programmatic way of storing data so that it can be used efficiently. All right, so if data is not organized, of course, it will not have any meaning. And so the data structure provides us with an opportunity to organize our data in different ways so that it can be meaningful. We may want to think about even like when you're doing a spreadsheet, think about how the data that is entered in the spreadsheet is stored by the computer so that when you open the spreadsheet, you're able to see all the information that you would have entered in the grids and so on. All right. So a lot of thoughts had to be put into that in terms of how the data is represented. As you can see with even things like the undo and the redo. So all of those had to be done at a certain level of consideration. Now, if you were to write a program to store the exam grades for maybe 20 students, which data structure would you use for a simple task like that? If you just want to store some grades, maybe a list of say 20 grades. Which of the data structures mentioned in the video would you use for that?
Stock data.
The stock. All right, the stock could be used, but something simpler than the stock. Something that you probably have used before.
The graph.
So we could use an array to store the grades.
Right. I think the array would be the simplest. The simplest are to implement for such a task. All right. So you could use the array for that one. All right. Good. So there are different data structures, but how we use them will be dependent on what we're actually doing. All right, so these were discussed in the video in terms of data being unorganized, can be viewed as raw material, raw or unprocessed material. When the data is organized into a meaningful form, it becomes information. All right, and of course, our data structure helps us to achieve that sort of organization. Now, the data that is entered into the computer is normally done using different variables in terms of collection. Now, the data type describes the type of information, type of data that a particular variable can hold. All right, so it determines what sort of operation can be performed on the data. So we have a variety of data types. Name some of the data types that you would have encountered in C++ and Java.
String, number, character,
Mm-hmm. Yeah.
string,
What?
number, string, character.
That's one of the data types that are used to represent the numeric.
Integer.
So you have
Yeah, integer, yeah.
Integer,
Real.
real. You have
Yes,
string, you have character. And
good. So you have string, character, integer. Still not hearing some of them. What if something is
Floating points.
all right? All right. So those are different data types that we have and we have used, in programming. Now, when we are implementing data structures, it's very important that we find methods and means of maintaining confidentiality in terms of the data that is being represented. And so if you remember when you were doing OOP, you would have created things like class and objects, which would provide you with an opportunity to achieve what is called data hiding and to an extent abstraction. So where you can, like for example, a class can be used to encapsulate your information. That is, we can wrap a number of information within one class and access them all through a common interface. So if we have a banking class, inside the banking class, we can have functions for deposit, we can have functions to get a balance and all of those. But then the user would just be interfacing with the banking class without knowing what the implementation within the class itself. And so we have what is called abstraction. And abstraction is basically the process of hiding the implementation details from the user. All right. So only the functionality that the user is really interested in, the user would actually be interfacing with. And it's very important that this is done, especially look at even a common example like within a car. I believe most of you probably can drive or have some exposure there. Now, we all know that when you press the brake, the car is supposed to stop. But if I should ask, how many of us know how the brake is actually set up? I am sure that most of us may not be, aware of it. But that is not important to us. All that is important to us is that when you press the brake, it stops. And so that is what abstraction does. It allows the programmer to hide the implementation detail from the user. And this actually helps to improve the level of integrity that is maintained for the data, because if the how the data is the implementation of the class or the data structure itself is not hidden, if aspect of it is not hidden, then of course, persons like hackers and so on will be happy because they can easily tamper with the data. And of course, we don't want that to happen. All right, so we have information hiding and abstraction. So both of them are somewhat similar. All right, but the main point here is that the implementation detail is hidden from the user. All right, now we have other concepts like encapsulation, and this is sometimes referred to as data hiding. And it's basically a mechanism whereby the implementation detail of the class is kept hidden from the user. All right. Now, the user can only perform a restricted amount of operations through encapsulation. That is the process I described earlier as it relates to class. So when you create a class, you can determine what the user can perform. So unless a method is on a public, so if the method is not on a public, the user can't access it. All right. So we achieve encapsulation by using different access specifiers and so on. And so to a large extent, it gives you, the designer, a certain level of authority as it relates to what the user can or what the user cannot do with a particular object of whatever you're creating. And so this is one of the strategies that is used to help maintain the data integrity when we are implementing our systems. Now, the other concept that we need to be mindful of is abstract data type. And what is an abstract data type? Based on what you did in OOP, what's an abstract data type? Anybody remember what an abstract data type is? Abstract data type. Describe. Okay. So what I described earlier, Travis, is a class, and of course, class is one of the tools that we use to create abstract data types. Somebody else was saying something?
Sir.
Yes? Go ahead. Go right ahead.
Sir, oh my God. Sir,
Abstract data type. That's it.
no, I know, but it just
Something about semantic behavior or something like that. I don't remember exactly. What's it?
All right. All right. So when you remember, you can share with us. All right. All right. So as Travis alluded to earlier, and I believe it was Deidre that was talking a while ago, even though we didn't really hear what you said clearly. So we're saying that an abstract data type is a type, or a class for objects whose behavior is defined by a set of values and operations. So remember, when we define a class, we define the data for the class as well as the operations that the class can perform. Now, the beauty about an abstract data type, for example, a class, when a class is created, we can use the class to create other data types. So if we define a class called bank, we can then create different objects of the class. All right, so we can create objects of the class. So the abstract data type, as the name suggests in this case, allows us to add to the pool of data types the programming language. All right, so our abstract data type allows us to add to the pool of data types. So we have the primitive types that come with the language, like the int, the double, the float, and all of those. But then we can add new data types through the use of ADT. All right, so whenever you create a class, you actually create a new data type that can then be used to define variables and objects. All right. Good. So the abstract data type, as the name suggests, actually allows you to basically specify the types of operation, the type of data that can be accepted by this particular data type and so on. And then if we look back in our OOP notes, we would be thinking about a blueprint versus a concrete implementation. So the abstract data type actually allows us to establish a blueprint of what the data type ought to be. And then we, in the context of a class, we are able to concretely implement it using objects. All right, I think there is a message from the chat. Let me just check on that. So the behavior is defined by a set of values and a set of operations. Good. All right, good. So
for example, sir.
Yes, go ahead.
Yes, I was just asking. So for example, like doing a program or writing a C++ program for the accepting of data for students' data on hall. The abstract data type would be like, for say, the different halls that we have, and then it actually signifies what information would go under that. So let's say bishop, and then for bishop you'd have like the different names of the persons in bishop house that would then fall under it.
All right, so good. So you could then have, in terms of an abstract data type, without being too specific, you could have like an abstract data type for hall, or you could have an abstract data type for a house. Think about the ADT as like a class. Think about, so you create a class. Let's say you create a class for house. Within that class, think about the things that you would collate for each house. You'd have like the members, and what are some of the things that persons can do, or what are some of the things that can be done. You would have things like registration and all of the actions that can be performed by the host. So you have to look at it in the context of, say, a class. And just think about the data to be collected, think about the actions to be carried out. All right. So it is similar to what we speak about when we're talking about class in OOP. But we will spend some more time looking at this. So we'll actually look at how to implement class in C++. All right, so we will actually look at this in a more practical sense. All right, but the beauty about the abstract data type is that it allows you to specify the actions and the data, and then ultimately it allows you to create like an object and to actually define the variables using this abstract data type that is created. Any question? Any other question? Silence. Hello?
No, sir, we're good.
Oh, you good. All right. All right. So we will touch back on this. This is not the end, just a preview of what is to come. All right. So we are now going to look at the importance of data in decision making. What role do you think data play in decision making? Do you think data influence decision making in any way? Is it important that we have accurate data?
Yes, it is very, very accurate. So, for example, we could look at Facebook, right?
Yes.
So you know that Facebook captures the data of people, and Facebook then uses this data to actually influence how many potential friends you could receive.
Yes.
So that's in the form of mutual friends and so on. So if Facebook were to get this information mixed up, then we would see where there's an inconsistency in the data that's actually stored in the Facebook system. Not sure if you get what I'm saying.
Yes, very good. All right, so it's very, very important. So if the data is not accurate, of course, it can throw off a number of things. All right. So you mentioned Facebook, and there are many other applications that actually track your movements, even your shopping pattern, and all of those things are actually captured from time to time to inform supermarkets how to stock their shelves and so on. Now, accurate information, as we mentioned earlier, allows for good decision making. If information is not accurate, of course, it can lead to loss of life and properties, and even, I mean, it can cause a business to lose out, especially in a time and space like this where we are going through a pandemic. If we do not have accurate information, our businesses, though they are now struggling to make a profit, may even plunge deeper into debt and bankruptcy if they don't receive accurate information. Think about self-driving cars. If these self-driving, yes, hello?
Would like, for instance, like saying that your mortgage is or something like that, so that would like be inaccurate information because it's not directing to the person that they actually want it to direct to, but instead it's going to somebody else. If you understand what I'm saying.
I didn't really hear the first part. You were saying something about your mortgage. If your mortgage does what? What did they say about the mortgage? I didn't hear the first part.
So I'm saying that, so for instance, it's supposed to go to say Travis. The message is supposed to go to Travis, but because of like a number mix up, like say you're supposed to have like a 5 at the ending of your phone number, and
yes,
you're write it and it look like 3. Is that like inaccurate information?
Definitely, because the data would have been entered incorrectly, and so the intended recipient would not be receiving his or her message. And of course, this is now going to lead to you being probably bankrupt, or it could even lead to you losing your properties because you're not honoring your obligation in terms of your mortgages. So it's very important that we enter data correctly, and of course, whenever it is entered, that it remains unchanged, unless it's gonna be changed by who is authorized so to do. All right. But yes, that's an example, of course. All right. So we see that would be an example from the point of data entry. So if the data is not entered correctly, then of course it can lead to a lot of problems. So think about a pilot programming the aircraft to travel probably 200 miles, but instead of putting 200, they probably set it to say 20 for just for argument's sake. Of course, this could lead to a number of problems. All right. So if at any point at all the amount of fuel that is placed in the aircraft is directly proportionate to the distance that it intends to travel, and that would really be a rather chaotic situation. All right. Now there are other scenarios. There are other scenarios where you would have seen so many flights failure in flights over the years, and a lot of this is really dependent on inaccurate information. All right. So data, so it's very important that we understand how best to represent data when we are writing our programs, so that we can mitigate against some of these mistakes, and so we can increase the level of efficiency when retrieving and when using our data and information. There are different levels of decision making. We have the strategic decision making, we have operational, and we have the tactile decision making. Now, strategic decision making has to do with decisions that are made according to a company's goal or mission. So decisions as it relates to the company's goal or mission, those are strategic decision making. Now, things that has to do with the everyday running of the business, those are said to be operational decision making. All right, so whatever decision is made on a daily basis as it relates to running the business, those are considered operational. And then we have the tactical, which represents repetitive decisions made by the manager in adherence to established rules and policies. All right, so there are different levels of decision making, but what is common at each level is that the information that is used to inform the decision making process is accurate. If the information used to inform the decision making is not accurate, if it's inaccurate, then of course it can lead to decisions that are made that may plunge the business into bankruptcy, may result in lawsuits, may cause a loss of life and properties. All right. So as computer scientists, we have a very important role to play if we're going to design organizations' information system. If we're going to write programs for organization, we have to be mindful that whatsoever we do actually help to maintain integrity and to preserve a company's data. One of the greatest assets to a company, to an organization, is its information. And so if information actually leaks, then that can really be problematic for the organization. All right, so there will be a discussion item. There's a discussion item for you on the Moodle, the learning management system. So this can be found on the lesson 1. So the instructions are here, so you can make your contribution to that forum. Now, information can be seen as a resource.
Before you continue, sir, the discussion, is it the same Moodle platform that was showing the 2 to 5?
Yes, man. Yeah, that is where we, and even this presentation that I'm going through, I have uploaded it there. Okay. So every course is there on the Moodle page.
I just wanted to confirm that it's under the one that showed 2 to 5 and there is not another Moodle platform.
No, that's the one. That's the one. Mm-hmm.
Okay, thank you.
Yes. All right. So as I said earlier, information is very, somebody's speaker. Information is very useful to an organization, and the information collected can either break or make the organization. All right, so the information is one of the most useful resources. Information informs, it guides. Based on the information collected, an organization can determine whether or not it is worthwhile to open a new branch in a certain location, whether or not it's necessary to continue to invest in a certain product, and so on. All right, so very important that we implement methods and strategies to organize our data and to maintain the integrity of whatever information our system collects. All right, now as it relates to data management principles, any question before we go into data management principles?
No, sir.
Just one question for me, sir. It's in relation to the discussion forum on the Moodle platform, where we'll actually give the response. We're on the Moodle, would it be under the, let's say, lesson one? Would it be under the pre-instructional activities then?
No, it will be on the
Okay.
lesson.
No.
I'll tell it as soon as I'm finished. Just
Okay.
inform me. All right. All right. Good. Right. So data management principles. Basically, data management is an administrative process. So you might be wondering, why are we talking about administrative process and we are computer scientists? All right, so we need to have an understanding of what goes on in an organization. If you're gonna create a product for an organization, you have to have an insight into what goes on in the organization. And so data management is basically an administrative process that includes acquiring, validating, storing, protecting, and processing required data. Now you come in as it relates to storing, validating, and protecting the organization's data. Now, if you check most of the well-established firms, especially in Kingston and across the island, we find that we have persons like data scientists being employed. We have data security experts and all of those personnels that are there to help to strengthen the backbone of these organizations. Because if integrity is not maintained, especially in a banking application, if integrity is not maintained and your clients are not comfortable that the data is kept secure and your data is represented in the most efficient and logical manner, then of course persons are going to lose confidence in that organization. And there are different techniques that can be used in data management. These are some of the techniques used to manage data. Basically, we want to ensure that the data can be accessed very easy. So simplify access. So you don't want to have the data stored in an organization in such a way that it's difficult to access it. It's difficult to retrieve it, especially when the relevant authorized persons are supposed to retrieve it. We also want to maintain and strengthen the data scientist arsenal with advanced analytical techniques. All right, so data scientists, it's very important that we design the system in such a way that the data scientist is able to analyze whatsoever is stored, is able to access what is stored in the most efficient manner. All right. The next technique is that the shape and flexibility technique that is used. So whatever data is stored, it should be able to we should be able to use that data to shape the organization, to manipulate that data to suit the organization's need as best as is possible. All right. And there should also be shared metadata across data management and analytics domain. And if you're wondering what metadata is really data about data. So when you're doing like a database and you would have created a table, you would have stored things about each field in the table. So for example, if you have an ID column, metadata for that ID column would be type of data that the ID ought to be. So if the ID ought to be just number, the metadata would indicate that it's number. How long or how many digits the number should be, all of those things form the metadata for that. If it's a string, of course, the metadata would indicate that it's a string, how long the string ought to be, and so forth. If it's something like an email address, the sort of pattern that should be used, and all of those, the metadata actually informs you about the data. All right, so in strengthening the data management principles, we want to ensure that metadata is shared across data management and analytics domain. So these are just some of the different principles that we use when we are managing data for an organization. Of course, we want to simplify access, we want to strengthen what the data scientists can do, provide them with tools and opportunities, of course, to use the data for their benefit. We want to shape the data in such a way that it benefits the organization, it's able to shape the organization, it's able to inform decision making and all of those things. So these are just a few of the different principles that we observe when we're talking about data management. All right, so data, enough said about data, very, very important part of an organization. Very, very important. And as computer scientists, as programmers, as database administrators, as developers of IT tools, we are interfacing with data. In today's day and age, we have what is called big data. And gone were the days when we would be looking at like kilobytes of data or megabytes of data, right? In today's time and age, we really have some real big data, and we ought to be mindful of how to handle these. And of course, if we do not apply appropriate management principles and strategies, then of course we will make it more difficult for the organizations. All right. Any question on data management principles?
No, sir. I guess where we is so far.
All right, good. All right, so primitive. What are some of the primitive types that we have in C++? What are some of the basic data types that we have in C++? Primitive data type.
Boolean or something like that. Char.
Boolean, char. What else?
Boolean. No, them there. Inter, float, and double.
Very good. So these are some of them that we have in C++. We have Boolean, char, int, float, double, and all of those. Now, the data type informs us as to what can be stored for each variable. So if a variable is declared as int, if the variable is declared as int, can we store the value 25.6 in it? If something is declared as int, can we store 25.6 in it for it?
No.
No, sir.
No, sir.
No. All right. And of course, if it is declared as double, can we store something in double quotes, double quotation?
Go again, sir.
If this string, if it is double, can we store a string in it?
I'm not here, sir.
You were breaking up, sir. Could you repeat that? If it's
Oh.
double, can we store?
String. So if we can we store a string in a
No, sir.
variable that is declared? No. All right.
No, sir.
Right. Good. So these are the primitive data types. These are the basic data types. These are what come with the language, and you guys need to know about them. Know what value they can store and what value they can't store. All right. So these are the very primitive data types, and of course you will get an opportunity to write applications using them, just to demonstrate that you actually understand what they are. All right. One of the most primitive data type, data structure that we have is the array. And what the array does, it provides contiguous storage for data of the same type. So the array stores data in a contiguous manner, that is beside each other in memory. So if the array is defined as type int, then of course it can only store integer. If it is defined as string, it can only store string. All right. What I'm gonna ask you guys to do at this point is open dev C++, and we are just gonna look at a few of the primitive data types. So I'm just gonna allow you now to open dev C++, and I'm gonna open my. All right. So once you have done your solution, I want you to share, each person to share what you came up with on the Padlet. There's a link in the chat for the Padlet. So you're gonna click on the link, and when you get on the page, there's a plus sign at the bottom of the page, bottom right hand corner. Click on it, and it will allow you to paste your picture or your text or whatever you are doing. Paste it there. So we're gonna use the Padlet to share what we came up with.
Sir, I think you actually had.
All right, so in programming, an array stores values of the same data type. Normally, an array is defined using a fixed size. So whenever the array is declared, we have to specify three main things. We specify what the name of the array is. You have to specify what the size of the array is. And we also have to specify the type of values that the array can store. So here we have an example of an array in C++. And the name of this array is grade. The type of values that the array stores is integer. And the amount of values, that is the size of the array, is 5. So from this statement here, we can tell three things about the array. So you can tell that the data type, its type is int, its size is 5. That means there are 5 spaces in memory that are reserved for this array. And the name of the array is grade. All right. So we're gonna look at this in C++. We're gonna look at this in dev. All right. So let's just look at this. Let me just bring back up my dev page. And let's look at how this is implemented. And this is considered to be a one-dimensional array. I'll just add it below here. So we have int grade, and the size of it is 5. And I believe we initialized it. No, we didn't initialize it. All right, so that's so in grade 5. All right. So this statement declares the array. So here we declare so that's how we declare an array in C++. So we declare this array. So somewhere in memory, there are 5 memory spaces reserved to store integers, 5 integers. All right, so if we should initialize this array, let's say I want to put some grades in there. Let me just initialize it. So if we were to put 5 grades in this, like 78, 3, good. So there we have 5 grades. Just declare these as still. And all right, so we here we declare an array, and this array is storing 5 elements. All right. Okay, so in C++, arrays are said to be 0 index. That is, the first array item starts at index 0. So if the array is size 5, what is it? What is the index of the last item in the array if the size is 5?
4.
Very good. So it's always 1 less than the size. All right. So the array the last index is always 1 less than the size. And in order to access an element in the array, we specify the array name along with the array's index. So if I wish to print out the first element of this array, then I will have to indicate the array name and the index. All right. So let's look now at how we would go about printing out the value 78. And pay attention to this one. Let me just show you something before we move on. So in C++, we say output grade. What do you think will be printed by this statement? If we just say cout grade or print grade, what is going to come out? All right, so if we print the name of the array is a pointer to the first element in the array. So this is what comes out. The name of the array is a pointer. We're going to be speaking about pointer later on. Everybody can see this?
Yes, sir.
Yes, sir.
All right, so this is a hexadecimal number. This is a hexadecimal number. I believe you'd have done hexadecimal in one of your math course. Base 16, so it's a base 16 number. Each location in memory is represented by a hexadecimal value. So the memory address for grade, the first grade in the array is this number. Just like each of you right now, you're located at a certain longitude and latitude on the map. That is why if you give us your location, we can locate you. In memory, each item that is stored in memory has an address. So this is the address for the first grade, that is for 78. Now, we're not seeing 78 here. What we're seeing is the address for 78. All right, so if we wish to see the actual 78, we would have to dereference this. Again, I'm just giving you a preview of what is to come. We dereference the pointer by putting an asterisk before the name. And if I run this now, you should see, instead of seeing the address here, you should be seeing the value. There's it. All right. Follow me? So the point here is that the first element, the array name is a pointer to the first element to be contiguous. So in memory, this is the first element in the array, and right beside 78, we have 59. In other words, if the memory address for 78 is address 1, then address 2 is going to be 59, address 3, because they are immediately beside each other, they are contiguous. All right, so we will look at other data structures that allows you. This is not necessarily a contiguous list, but the array list is contiguous. So if I say grade plus 3, if I say dereference grade plus 3, remember grade is the address of the first element. All right, so I'm just showing you another way to access the elements in the array. So grade by itself will give you 78. If I say 3 spaces after grade, that's what this is saying, 3 spaces after grade. So this is where grade is, but 3 spaces down the line is 1, 2, 3, that's 95. So when I run this program, I should be seeing 95. So let's run that.
Sir, I posted a question in the chat section of the app.
So there is 95. What if I want to print, what if I want to print 74 using this method? What should I put? Grade plus what?
4.
Grade plus 4. Yes, you're very correct, Gabriel. Grade 3 could also be, grade 3 would give us what? This is grade 0, 1, 2, 3. Yeah, grade 3 would give you 95 also. Good. So this is just another method of doing the same thing. All right. So if we say grade plus 4 here, we will get 74. All right. Good. Let's click on this form. So this is just another way of printing the elements in the array, or accessing the elements in the array. So here it is. All right, so here's our sentence. Right, good.
Sir,
Yes.
everything is coming up as 73.5 for me. I don't know why.
All right, everything coming up at 73.5.
Yes.
Oh, did you comment out the CO here? Probably you're getting the output from the CO. Actually commented out this one. That's when we multiply 21 by 3.5. So I commented out this, so we just focus on this. All right, so comment that out and let me know if you're still seeing that. All right, so the other strategy to print the elements in the array, so if I want to print 82 using the traditional method, what I would do is to say something like cout grade followed by the index. What's the index of 82? What is the index of 82?
That is index 2.
Right, so index 2. So this one is 0, this one is 1, and this one is 2. So if we say cout grade 2, it should be seen 82. Let me just put a new line. And put method 2. All right, so this will print out 82 for us. Right, so we're printing out index 2. Again, if we wanted to use this method, we'd have to just dereference the pointer, the grade pointer, and say grade plus any amount of distance is from the first element. So it's gonna be 1, 2. It would just be grade plus 2. So asterisk grade plus 2 would give it the same thing as what this is doing. All right, so there are two different ways of accessing the elements in an array when we are using C++. And the array that we are using now is referred to as the 1D array. It's a one-dimensional array. So this is the one-dimensional array. Let me just run this. So that's all right. So in C++, as stated earlier, the array may be multidimensional, and this type of array has rows and columns. So in declaring the array, we have to specify the array name, the array type, the amount of rows, and the amount of columns. And here we have a table that represents just a little pictorial of what the multidimensional array looks like. So if X here was 3, it means that we have 3 rows ranging from 0 to 2. So this being the first one, the second one, and the third one. And because it's index 0, the first one starts at 0, and the last one at 3, at 2, sorry. For the column is represented by Y. So in this case, the amount of columns here is 4, so Y would be 4. So the index would be from 0 to 4, or 0 to 3, sorry. Now, so the first element that is right here is going to be 0, 0. Here, in the second row, it's going to be A1, column 1. So A1, 1 represents whatever is here. I'll just do a quick example in dev so we can actually see what is going on. Let me just bring back my dev screen. So here we have a multidimensional array. Let's call it spreadsheet. And we're gonna put about 5 rows and 5 rows and about 3 columns. Right? That means this is gonna be equal to, I'm gonna initialize it as well so you can see what you're talking about. And this will help you. I'm just gonna put these down here so you can see. All right. I could actually type everything in one line, but I'm typing it like this so you can see what we're talking about. So in the first row, and these I'm gonna type in like this. So in the first row, I'm gonna put in some values. So I have 3 rows. I have 5 rows and 3 columns. So 5 rows. So for each row, let me put in the data for each row. So I have 12. That's 1 row. Right? And we have 5 rows. So I'm gonna put in other data. 90. So 3 columns. So remember, it's 5 rows. The row runs from left to right. That is horizontally. So they're gone 3 rows now. We need a 4th row. And we need a 5th.
So you have to put a comma on the outside of each row to separate it.
Right, yes. Except the last one.
Okay, thanks, sir.
All right, so this is what it looks like. So this is an array. So this array has 5 rows. 1, 2, 3, 4, 5 rows and 3 columns. That's 1, 2, 3. All right.
Sir, so the semicolon goes on the outside of the other closing, right, sir?
This one, yes.
All right, thanks, sir.
All right, so I really type it like this for readability, so persons can actually see what it's actually looks. The truth is everything could be typed in one line when across, but it will look a bit jumbled. Now, if I wish to access 54, what if I want to print out 54? If I want to print out 54, all I would say is the name of the array is spreadsheet. Specify which row 54 is in and which column it's in. Which row is 54 in?
Column 2.
Which row?
Column 2, row 2.
Row 2. All right. It's in the third row, but the index for the third row is 2. All right, so it's 0, 1, 2. All right, good. So I'm gonna put 2 for this, for the row. And which column is it in? Which column is 54 in?
It's in the second column, but the first index.
All right, so the index is gonna be, indexes from 0 to is 0, so this would be 1. All right, good. All right, so the 1 represents the second column. All right, I hope we're all following. So if I run this, I'm going to see 54 coming. All right, so I'm gonna see 54. All right, there is it, but it's actually beside the 82. So I'm just gonna create a new line so you can see by itself. Let me just add a new line. And all right, so there's it. All right, so that's how we access the elements in the multi-dimensional array. All right, so my part of the job is finished now. What I'm gonna do, I'm gonna share with you a Padlet link, and what you're gonna do is you're gonna use whichever method possible, whichever method you would like to use. You want to use a loop as well, and I want you to print all the elements of all the elements, print out all the elements in the array, in the grade array, as well as the elements in the spreadsheet. Right, so I want you to print them out, and I want them to be printed like the spreadsheet values on the screen. I want them to be printed out in the format that I have them presented here. So I want to see 3 distinct columns and the 5 rows as indicated. All right, so I'll just share the Padlet link, and you will do that. All right, it's now 4:13. We'll just wrap it up here. You can continue making your posts to the Padlet. I will review them. Also, just to remind you that we meet next week, so we'll pick up next week at the same time. We'll pick up next week at 1. So if you have any questions, feel free to share them, and stay tuned to the eCampus for further updates, and of course the WhatsApp group. We can use the same WhatsApp group and share our communication.
Before you go, sir,